glad you're here. Welcome to Models and Agents, episode 87 for June 20th, 2026, your daily AI briefing. There's signal and noise in AI every day. Let's get to the signal. Virtuals just wired Leyten's distributed GPU engine into its agent network to run GLM-5.2 at scale. A security report out this week flags active exploits targeting Langflow and related agent frameworks. A major security report details active exploits against Langflow and related frameworks. Builders should audit any self-hosted agent tooling this week. Patches for LangGraph, Langflow, and LangChain Core are already available. Teams should verify upgrades before the next wave of reported exploits. The report highlights risks in self-hosted agent tooling. Related frameworks face ongoing exploit activity. Verification of upgrades is recommended ahead of further incidents. Teams running self-hosted tooling should audit upgrades before the next wave hits. The Virtuals integration now routes GLM-5.2 calls through Leyten's distributed engine. Agents execute without managing individual GPU nodes themselves. Existing Virtuals users get immediate access to the model on the new backend. The move follows earlier reports that the same model performs well on fast custom silicon. Other agent platforms are already watching whether similar distributed backends appear soon. This development sits in the ongoing maturation of agent tool use tracked since episode 86. VibeThinker 3B is a 3 billion parameter dense model built on Qwen 2.5 Coder 3B. It uses the spectrum to signal post-training pipeline. The model reaches parity with DeepSeek v3.2 and Kimi K2.5 on verifiable reasoning benchmarks. It ships under an MIT license that permits commercial use and fine-tuning. Builders focused on code or math tasks can now compare its 3 billion scale directly against larger open-weight families. This release continues the narrowing performance gap between open-weight and closed frontier models noted in episode 85. MinFlux offers a minimal PyTorch reimplementation of both Flux 1 and Flux 2. The repo supplies explicit VAE and transformer components along with line-by-line mappings to the Hugging Face diffusers library. Training and inference loops use flow matching and Euler ODE steps. Flux 2 updates transformer blocks, modulation, FFN, VAE normalization, and position IDs over the first version. Anyone studying diffusion architectures can run the loops locally without the full diffuser's abstractions. DVD-GEPA demonstrates a minimal joint embedding predictive architecture on a bouncing logo video task. A context encoder, EMA target encoder, and Leyten predictor learn 32-dimensional representations without labels or a decoder. An optional decoder lets the model dream correct future frames for roughly 20 steps before drift sets in. The entire project runs in the browser through a 40-line JavaScript re-implementation of the trained MLPs. A new open handbook covers LLM inference at scale with chapters on GPU internals, KV cache behavior, and batching. It explains why GPUs sit idle during generation and where memory bottlenecks occur, complete with mermaid diagrams. The latest section walks through VLLM, SGLang, and TensorRT LLM trade-offs. Practitioners can review the GPU internals chapter to sharpen their mental model of production inference. This handbook directly addresses the AI compute and inference questions tracked since episode 86. SUI deployed SEAL-MPC on mainnet to give AI agents secure multi-party computation. SUI deployed SEAL-MPC on mainnet to give AI agents secure multi-party computation capabilities. The feature allows agents to perform joint computations without exposing private inputs. The feature lets agents perform joint computations without exposing private inputs. Teams building workflows that require shared secret handling now have a production-ready on-chain option. Teams building agent workflows that require shared secret handling now have a production-ready on-chain option. The deployment occurred on mainnet. It supplies secure multi-party computation for agents. NVIDIA AI released Spatial Claw, a training-free agent that writes and executes Python inside a persistent kernel for 3D spatial reasoning. It composes existing perception tools through code rather than learned policies. The approach removes additional training while still handling complex spatial queries. Developers working on robotics or 3D scene understanding can test the code as action pattern immediately. Atomic Mail now lets agents create and manage their own email inboxes with no human account creation step. Atomic Mail now allows agents to create and manage their own email inboxes autonomously. No human account creation step is required. The service targets agent workflows that need persistent, independent email identities. The service targets agent workflows that need persistent, independent email identities. Agents can register their own inboxes with no human involvement. The release enables autonomous inbox management. It removes any requirement for human account creation. Dataset Apps reimagines Claude-style artifacts with a full relational database and JSON API backend. Dataset Apps gives developers the interactive artifact experience, but backed by a full relational database and JSON API. HTML plus JS applications can read and write structured data directly instead of relying on local storage. HTML plus JS applications can read and write structured data directly instead of relying on local storage. The project post includes live demo details and UV one-liners for quick local testing. The project blog post includes live demo details and UV one-liners for local testing. It provides a relational backend for artifacts. Applications gain direct data access through the JSON API. A recorded workshop posted to YouTube covers the full LLM stack from perceptrons through pre-training, instruction tuning, and RL. The recorded workshop covers the full LLM stack from perceptrons through pre-training, instruction tuning, and RL using slides, Excel examples, and PyTorch code. It uses slides, Excel examples, and PyTorch code with no prior machine learning background assumed beyond comfort with code. No prior ML background is assumed beyond comfort with code. Slides and exercises remain available for self-paced study. Slides and exercises are available for self-paced study. The workshop teaches ML, LLM, and math intuition. It assumes only basic comfort with code. Yandex open-sourced YAF, a zero-copy wire format for protobuf that offers 4 memory layouts. The flat layout reaches 1.2 times the speed of a raw C++ struct in benchmarks. Production advertising systems have already reported 10 to 20% CPU savings after adoption. Time Copilot supplies an end-to-end forecasting pipeline that combines statistical, foundation, and GPU-accelerated models. Time Copilot provides an end-to-end workflow that combines statistical, foundation, and GPU-accelerated models with rolling cross-validation and probabilistic forecasts. It includes rolling cross-validation, probabilistic forecasts, and an optional LLM agent that selects models and explains predictions. An optional LLM agent can select models and explain predictions. The tutorial demonstrates the workflow on real airline passenger data plus synthetic series with injected anomalies. The tutorial uses real airline passenger data plus synthetic series with injected anomalies. It supplies automated anomaly detection. The pipeline supports foundation models. Okay, let's pop the hood on flow matching as it appears in the MinFlux implementation. The technique reparameterizes generation as learning a velocity field that transports noise to data along straight paths in probability space. The model therefore predicts the instantaneous direction of the probability flow rather than a score or noise estimate. Straight paths let the O-decimal decipher solver take larger steps at inference time and cut the number of function evaluations required. Training pays a cost because the velocity target must be estimated from paired noise data points, which raises gradient variance compared with the simpler noise prediction loss. In the min-FLX loop, the VAE first encodes images, the flow matching velocity is computed, and an MSE loss regresses against that velocity. Choose flow matching when your inference budget is dominated by solver steps. Stick with classic diffusion when training stability matters more than step count. Try the virtuals plus Leyten integration if you already run agents that need fast GLM-5.2 access without managing GPUs yourself. Clone the MinFlux repo and run its training and inference loops to study flux internals without the full diffuser's complexity. Test Vibe Thinker 3B on code or math tasks, where you want DeepSeek level reasoning at 3B scale under MIT license terms. Walk through the dataset apps, demo, and UV one-liners to see how a relational backend changes what HTML plus JS artifacts can do. More agent platforms are expected to announce distributed inference backends for GLM 5.2. Patches for LangGraph, Langflow, and LangChain Core are already available. Yandex, YaFF, may appear in additional protobuf-heavy pipelines as the reported CPU savings spread. Tomorrow, keep an eye on whether additional agent platforms confirm distributed backends for GLM 5.2. That wraps up today's AI briefing. Share this with a developer or builder who wants to stay current. Subscribe wherever you listen. See you tomorrow, and before you go, this show is part of the NARA Network, a family of daily podcasts covering tech, science, markets, and more. If you enjoyed today's episode, give OmniView a listen. A balanced daily world news briefing that takes every side seriously. You can explore the whole lineup at neuronetwork.com. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.